So guys, let's kind of pick up where we left off and see what we got for this. Hopefully you know what's going on. And I'm going to record this for Jake as well so he can watch it later on. Alright, so where did we leave off? I think, Kristen, we left off with you? Okay. Alright, so guys, let's come back together and see how we did for number 4 now. Kristen, for number 4, what is it telling us? What direction are we approaching it from? The left. So which equation can I cross off? The bottom one. Okay, so I know I'm going to only be using the top one. And in this case, Kristen, can I just plug and chug? Yep, so I'm just going to go ahead and plug in 3. And what did you get as your final answer? 5 over 2. You agree with your guys?
Yeah.
Yep, looks good. So that means our limit would equal 5 over 2. Looks good. All right, come over to you, Dimitri. Look at number 5. Since it says the limit as x approaches 2, what are we going to have to prove in this case?
So you have to prove that they both equal 2.
Okay.
Not 2, but that.
Yeah, when you plug them in, you get the same answer. So I'm going to plug it into the top equation first. So this is coming from the left-hand side, right? What did you get when you plugged it into the top equation?
2.
2? Okay, good. And now I'm going to come from the right-hand side. Guys, be really careful. This is something I see a mistake a lot of times. This negative means gets applied after you do the square, okay? So what did you get when you came from the right-hand side?
2.
2. So what does that mean?
The limit is 2.
Yep, the limit equals 2. Very good. Okay. All right, Stephen, for number 6, what do you have to do in this case? It says the limit as x approaches 1.
Put them into both the equations.
Okay, so you said they both equal the same thing? See if they do. Okay, so on the left-hand side, as we come from the left, the top equation you got, what did you get? 2. And as we come from the right, what did you get as well? 2. All right, so what does that mean? Equals 2. Okay. All right, let's see, Eric, how about number 7?
For number 7, just plug in 1 minus x.
Okay. Yep, because we're coming from what direction?
The right.
Very good. Okay, so it just means it's going to equal 0. All right, so far so good? All right, flip over to the back. Maddie, when you look at number 8, what are you going to have to prove for number 8 or show? Is it going to be all of them, or is it just going to be the left and right-hand side? Do we have to? Yeah. Okay, so let's see. If we plug it into the top one, Maddie, what is cosine of 0? 1. Good. So 3 times 1 is just 3. And Maddie, if we plug 0 into the bottom, what do we end up getting out? We get 0. So is the limit going to exist? No, it does not exist. All right, number 9 is something you haven't seen before, but it says it's the limit as x approaches 1 from the right-hand side. What do you guys think you can do, Marissa? You can just plug it in, right? If it's continuous at that point, it doesn't matter if we're saying from the right or from the left or just the limit in general. Just plug it in. So if you plug it in, oh, actually, I missed you guys over there. Alexa, if you plug it in, what do we get?
5.
Good? Okay.
Those are my favorite ones.
Yes, they're very easy. They're very fun. Although, we're soon to get to even better problems. What did you say? Algebra 1. All right, this problem here, guys, whenever you approach a limit, you always try to see if we can just plug and chug, okay? Now, if when you plug and chug, you guys, this is review, if we get 0 over 0, what is that called?
Indeterminate.
Indeterminate, right? And we have to use one of our 4 strategies, right? We can factor and cancel, we can rationalize, we can simplify a complex conjugate, or we can simplify using known trig limits, right? Now, in the video clip you just watched, they talked about another situation. You get a number over 0. What does that mean? Vertical asymptote. So we're going to have to figure out, how do we figure out whether it's approaching positive or negative infinity in that case? Okay, so that's kind of what we're going to be moving into. So let's first just test this out. So I'm just going to do a little test here. And if I plug in 2, guys, to this function, what do I get? 0 over 0. So I know that this is indeterminate. Okay, so I'm going to have to use some sort of strategy to see if I can figure out this limit. What strategy could we use? Yeah. Factor and cancel. So let's go ahead and do that. So I'm going to rewrite this. So the limit as x approaches 2 from the right-hand side. How does the bottom factor, guys?
X plus 2, x minus 2.
Yep, x plus 2, x minus 2. So I go ahead and cross those out. Am I now allowed to plug in 2? Yes. So I'm going to be, 1 is still a placeholder on the top. If I plug in 2, what is my denominator? 4, right? And does it matter in this case that it says from the right-hand side? No, right? Because whether it's coming from the right or the left, I'm still going to get 1/4. All right. Yes.
How do you know you don't do that like non-removable individual?
They're not asking what sort of discontinuity. They want you to find the limit. So Megan, your answer is going to be some number, or it could be infinity, negative infinity, you'll see in a moment, or it's going to be does not exist. Okay?
Wait, how did you get
Once I just plugged it in. Once I removed that, right, that hole.
so you just did x plus 2 plus
Well, x plus, well, 2 plus 2 is 4, and then 1 is the, yeah. All right, go down to number 11. So first thing you always want to do is test it out. So let's do a little test here. And if I plug in negative 2, what do I get on the top? Be careful. Negative 4, so I have some sort of number on the top here. If I plug in number negative 2 on the bottom, what do I get? 0. What does that mean is happening at this point? There is a vertical asymptote at negative 2 here, okay? So what I'm going to do is I'm first going to go ahead and simplify it if I can. So let's go ahead and do that. So I'm going to simplify it a little bit. I'm going to say, okay, I know I can factor it. So I have x minus 2. I have x plus 2. Right, it's the same problem from before. Cross out my x minus 2's. So I'm going to rewrite this. The limit as x approaches 2 from the right-hand side of 1 over x plus 2. Okay, so I've simplified it. Oops, it should be a negative 2. Sorry about that. Thank you very much. Okay, so I've simplified. The only issue is if I still plug in negative 2, am I still going to get some number over 0? So there's a vertical asymptote there, right? There's no way that we can remove that. There's a vertical asymptote. So what I need to think to myself is I need to figure out where or what is that vertical asymptote approaching, okay? So if you think about the graph of negative 2 here, this was your graph, right? And we were coming from the right-hand side, what would be a number right before we get to negative 2? 1?
No.
Or we could do 0 or negative 1, right? What number would you guys like to choose?
Negative 1.
Negative 1? Okay, it doesn't matter what number you plug in. Let's see what happens if we end up plugging in negative 1, okay? If I plug in negative 1, I get a positive number on the top. If I plug in negative 1 on the bottom, what sort of number do I get as well? Positive. So do you think this is approaching positive or negative infinity? Positive infinity, okay? So the answer here would be positive infinity. And if you think about this graph, you guys already know what 1 over x plus 2 looks like, right? You've practiced with that. You know that there is a vertical asymptote. Since it's not reflected over, you know it's approaching that positive infinity as well, visually in your head. Okay? All right, let's try another one. Don't worry. We're going to get lots of practice with this. Okay, go down to number 12. First thing is you always want to test it out. So let's do a little test. And if I plug in 3, what do I get, Mia, in this case? Yeah, you get some number over 0. So what does that mean is actually happening here? Yeah, either negative infinity or infinity. We know there's a vertical asymptote. If we are coming from the right-hand side, what would be a number right before we get to 3? We're coming from the right-hand side. Do we agree with her? Yeah, before. So let's do a little test and say, okay, we were to plug in 4 here to figure out whether it's positive or negative infinity. We end up with, let's see, it's going to be a positive number. And if we plug in 4 down here, we end up with what? Positive number. So what do you guys think? Positive or negative infinity? Positive infinity. Very good. Okay. And again, I taught you to become very comfortable with these graphs, hopefully. But if you thought about this graph, you know there's a vertical asymptote there. You know it's approaching positive infinity as you're coming from the right. Okay, so visually, and or I guess graphically and analytically, hopefully you're seeing what's going on here. Okay. All right, let's go down to a problem that's a little bit more challenging. Go down to look at number 13 with me. Before I start giving you some of the limits, let's kind of see if you can simplify this a little bit. On the top, we have x plus 2. That can't change at all. On the bottom, how does that factor? It's going to be 6 and 2. No, it has to add up to negative 4. Yeah. X plus 2, x minus 6. Okay, so before we think about the limits, what are some possible discontinuities here?
Positive 2.
Okay, at x equals negative 2, we know is going to be a whole. Okay? Yeah, but at x equals 6 we know is an asymptote. Okay. All right. So let's talk about if we were approaching -2 from the left-hand side. Okay. So if I'm plugging, or if I'm approaching -2 from the left-hand side, you can see that if we would have plugged it into these first original or equations here, we would have ended up with 0 over 0, right? So it's indeterminate. If I then use one of my strategies to factor and cancel, am I allowed to just plug in -2 to this new one here? Yeah. What do I end up getting? I get 1 over what? -8. Good. How about if I say, what is the limit as x approaches -2 from the right-hand side? Can I just plug and chug? Yeah, that's okay. So let's plug in -2. So I get 1 over what? -8. Yeah, Megan, what's up?
I don't know how to use the big.
Oh, I'm telling you what the limit is there. Your questions would always have it in there. I'm just telling you put it -2. All right. All right, so therefore the limit as x approaches -2 is? Yep, -1/8. All right, so guys, when you have a hole there, you just have your limit still existing, the same thing from the left and right, okay? Let's go over to the other side. What if it was the limit as x approaches, and I'm telling you this, Megan, 6 from the left-hand side, okay? So you know there's an asymptote here, so like Mia said, it's going to be either positive or negative infinity, right? And we need to think about what would be a number before we reach 6 if we're coming from the left-hand side. 5, okay, so if we were to plug 5 into this, we end up with a positive number. If we plug 5 into this, what do we get on the bottom? Negative number. So what do you think we're approaching, guys? Negative infinity. Very good. And again, if you thought about this logically, this graph, 1 over x minus 6, you know at 6 there is a vertical asymptote, and as you are coming from the left, you know that your graph looks like that. Okay. All right. How about if x approaches 6 from the right-hand side? What's a number we could plug in to test out whether it's positive or negative infinity? 7. Okay, so we know we're going to end up with a positive number on top. How about on the bottom? Positive number. So what do you think we're approaching? Positive infinity. Good. All right, last one. As x approaches 6 of f of x, does a limit exist if we're approaching different values from the left and right? No. So it's going to be d and e. All right, guys.
If you have negative over
Negative,
would
what
that be positive?
Very good. Very good. All right, why don't you guys try 14 on your own right now? So see if you can figure out. First thing you do is you always test. So you say, okay, if I actually plug -2 in, what's going to happen? So if I actually plug in -2, it looks like I get some number over 0. So I know that's going to be positive or negative infinity. So hopefully you guys all have gotten to the point where you see that it's going to be positive or negative infinity, right? There's an asymptote there. If it's -2 from the left-hand side, what would be a good value to test out? What type of 3? From the left side. -3, right? That could work. Yeah, so try plugging in -3 and see what infinity it's approaching. So if you plug in -3, you're going to get some sort of negative number on the top. You're going to get some sort of negative number on the bottom.
Infinity.
So it'd be infinity. Very good. That was actually the question that you just asked. Yeah. It's if you're trying to figure out whether it approaches infinity or negative infinity, the numbers don't matter, Maddie. You're just trying to figure out whether it's positive infinity or negative infinity. So if you plug in negative, yeah, it could be -3, it could be -4,
Negative 100.
-100. Make your life easy. Try to get as close as possible. Megan? You're good? All right, guys. That is everything in terms of limits. Okay, so we've kind of wrapped it up all together. What we're going to go ahead and do, I'm going to stop this here.